Hello everyone, and welcome to this presentation. We've given it the title From Single Stack to Multi-Stack Modular Electrolyser. So this session, it will be on electrolyzer. And I think I have a very strong and a very interesting story to tell you today, because we will bring you some real-life examples from a case study that we have done in our company concerning a 6 megawatt electrolyzer. So before we dive into it, just a few words about myself. So my name is Troels Boysen. I've been working with green hydrogen systems since 2021. Before that, I worked more than 10 years with the Danish energy developer, Ørsted. And also with me today, I actually have the special guest star, as you can see in the back, which is a 6 megawatt electrolyzer, but I will come back to that in just a few seconds. A few words about green hydrogen systems. You can see a photo here of our headquarters. It's based in Denmark. And here you can also see our factory, which is a 400 megawatt electrolyzer factory. We were founded in 2007 in Denmark. We are currently more than 300 employees, 50% in the technical functions, meaning R&D and production. We have a yearly production capacity of 400 megawatt. Currently, we have a backlog of more than 30 megawatt of electrolyzer deliveries, and it's mostly for projects in Europe. We have a few outside, but the focus is currently on the European market. The company was taken on the Copenhagen Stock Exchange in 2021, where we did an equity raise to fund all the investments in the people and in the factory. All right, so 4 years ago, we started to think that we wanted to make an upscaling of the current technology from the more single-digit megawatt electrolyzer to multi-megawatt electrolyzer. And we had extensive engagement with the market, with our customers, with key collaboration partners, as well as the internal team inside Green Hydrogen Systems. And we wanted to come up with the concept for how we achieve the upscaling of the electrolyzer technology in the best possible way. The outcome of that process has been summarized in this slide here. So the aim was, of course, to make a multi-megawatt electrolyzer. We wanted it to be modular so that you can configure to a site, depending on whether you need 50 megawatt or you need 100 megawatt or what you need. It should be modular so that we can replicate the product and achieve the scale quite easily. Also, we believe that we have to do standardized products. In that sense, we are quite inspired by the wind turbine OEMs. They make standardized products, they make series products, and they produce these products in a large volume. And this is the way that they achieve the cost out. So we've been very inspired by that, and this is also something that has gone into our thinking in terms of development and scale-up. We have to achieve a low footprint. Footprint is of essence, we just know that. We have multiple interactions with customers, and all they tell us is that we have to reduce the footprints as much as possible. In addition to that, the electrolyzer, of course, must be flexible, it must be efficient, and it must be reliable. So we took all these inputs and we said, okay, we have the current product, which we call the High-Provide A-Series. And it is a modular, it's a plug-and-play solution. And then we told our good engineers, come up with a good solution for how we scale up from the more small-scale product to the large-scale product. And what the engineers then did, they said, okay, we will use the LCOH as the guidance star for how we do the concept. And we want to also stay with the product that we already have and which we know is functioning. So we've divided this into 3 pieces here. So concerning the stack, we already have a good stack which is pressurized alkaline. And we said, okay, we will make this stack bigger. So we go from 124 cells to 207 cells. But in the product, the engineers also found out that we want to make 6 stacks, and we want to couple them together with the same balance of plant. And this is what you can see then in the middle part. So if you look at the balance of stacks, we have integrated into larger components and thereby, of course, achieving cost out. Because you don't need all the small components, you want to make them bigger. That's fairly obvious. So we've made the balance of the plant, or the balance of the stack, 10 times bigger if we compare to the 1 megawatt product. And then on the whole system, we maintained the idea that it should be modular and it should be scalable in that sense. And therefore, we arrived at the solution for this 6 megawatt electrolyzers, as you can see on the right side here. In front, we have the process module. So inside here, we have the stacks. They are electrically connected 2 and 2 and 2, so they are 3 series. On the gas side, they are actually one system. It includes, of course, the balance of the stacks and some of the hydrogen conditioning also inside there. Behind, you have the power supply, which is transforming the power. It could be 10, 20, 30 kilovolt. And then there are rectifiers, and they are then supplying the DC power to the stacks. It delivers 1,200 cubic meters, 107 kilograms every hour. The purity can be up to 99.998, so suitable, for instance, for fuel cells. The efficiency on the system is 54.7 kilowatt hours per kilo of hydrogen, and the outlet pressure is 35 bar. So all in all, quite impressive. This was the design. Now comes reality. Because we have a full-scale plant in Denmark, which is actually running as we speak. And as you can tell, we are quite proud of that. It has been an amazing journey. What you see here is the site. We have the electrolyzer inside the tent. In the middle part, you can see how it looks on the skid with the stacks, the separator scrubbers, etc., to all the balance of the stacks. We have the control cabinet on the bottom left, the piping, which is hydrogen, but also the water and the air and the nitrogen, which is needed for the process. And on the right side here, you can see the power supply for the unit. We've done this site together with a partner, an EPC partner called BWSC. They've taken care of all the scope that we as an OEM do not provide. And through this partnership, we have really gained a lot of good and practical learnings when it comes to how you execute an EPC project, when it comes to how you install an electrolyzer. We have also gotten extremely valuable insights when it comes to commissioning of equipment. It's a different animal commissioning a large-scale electrolyzers compared to our more small-scale electrolyzers, as we have had before, and we still have, of course. But that learning and taking that learning step has been really valuable. We are also getting insights into operating, so how you operate an electrolyzer on a large scale, and of course also very much, how to service, what are the key features when it comes to the service phase of the electrolyzers. All these learnings we are taking into the commercial deliveries that we are preparing for as we speak. So we got this equipment up and running just before Christmas last year. It went really well. We powered it up. It worked. And some few bugs, of course, but within a week, the system was running at full load. It was running according to the specifications. And we did some further testing through January. And then middle February, we actually did a performance test to validate the technology. We did that together with an independent third party. So there was a guy there with all the calibrated equipment. He was witnessing the performance test of the equipment. We tested transition times. We tested dynamic response. We did performance test. We checked the gas quality. And as you can see here with the front page, we got this test report out of the performance test. And it was then signed by the independent third party. To give you some of the insights from the performance test, we were able to start up the system and get to full load within 20 minutes. Or maybe I should start by saying that all this was done sort of at the very start of the life of this pilot. So this is sort of reflecting the beginning of life, you could say, from the test. We have done this test, and we will continue to optimize on the system, and then we will reperform the test as well with the optimizations implemented. But the beginning of life test showed that we can ramp up to full load in 20 minutes. We were able to validate the minimum load to be 20% of full load, up to full load, of course, the 1,200 cubic meters per hour. And we could ramp, at that time, we could ramp from 20 to 100% within 40 seconds. In terms of the performance, we were able to demonstrate the 107 kilograms. We were also able to demonstrate a specific energy consumption of 55.9 kilowatt hours per kilo. And also we were able to validate the outlet pressure of more than 35 bar G. So that was, in our opinion, very strong results from this electrolyzer pilot that we've done. So the process that we are going through now is we have validated the prototype. We did that in the first quarter this year. We will deliver 4 units of what we call a Mark 1.0 towards the end of this year, beginning of next year. And then towards the second half of next year, so 2025, we will deliver the Mark 1.1 generation to the market. We also know that collaboration with EPC players is an enabler for the electrolyzer scale-up. So Green Hydrogen Systems have teamed up with BWSC, and we have also teamed up with Bilfinger, the German EPC, to reach a concept that we can standardize and that we can go out to the market and make as a more integrated offering from us together with these partners. So that concludes my presentation. I hope you enjoyed it. If you have further interest, we are at booth B62, and you can come and have a discussion with us. We do have a virtual tour of this pilot that we've done, so you are able to see that. And also, we do make customer tours. So if you have an interest to see the equipment in real life, in real operation, that's actually also an opportunity for us. So for that, I thank you very much for your attention and have a good day forward.